All right, welcome back. This is Flatland Relics. My name is Matt, and today you're going to see me continue to work on the Chrysler 1968 A-833 4-speed. It's just a regular 4-speed, no overdrive, didn't change any gears, and for the most part, it's almost completed. The rebuild has gone so-so. It's the first time I've ever rebuilt one. There's 2 other videos on my feed if you would like to watch them. I have a teardown video on it as well. Here I'm doing some speedometer gear and the little speedometer housing, figuring out how to get that all together, putting the new rubber grommet in there. The book will tell you how to press that back down and how far to set it, and I think it suggests like what kind of tool to use, but yeah, you got to get it all the way down in there. And like I said last week, I do pretty good mechanic work on cars that are literally just above beater. So, if that's what you like, hang out and watch. If you're a seasoned transmission builder, this might not really be that interesting because, like I said, this is my first rebuild on doing one of these or doing any transmissions ever. So, obviously it's not as smooth as it could be. I lucked out. I was able to use the end of the shift fork there to get that little rubber piece in. I think I set it all the way with the screwdriver. I did not luck out when I ordered shift forks because I ordered one incorrectly. One is for lever type cover plate, and I have ball and detent. So I have one shift fork that works and one that doesn't work. And that is why you have not seen me finish the cover plate yet. After that came in wrong and I realized it, I was kind of bummed. I'm going to wait a little bit to order that again. It's just a pain in the ass when things come in wrong. We've all been there. We've all ordered some little part, wait for it to show up, anticipating to do the work, and no, the part is wrong. And I didn't realize that until I had the shift forks in the transmission. So that's how far along I got. One of the things that'll be interesting about tonight's video is beyond assembling these couple little doodads for the rest of the tail housing, I actually built a tool to set the tail housing seal. And I kind of show you the process I use to do that. You can buy a tool. I believe the press for that or whatever, there's like a driver for that, and I think it's like $90 or something. And I just couldn't make myself spend another $90 on basically a round piece of metal. So I go through and find something that works and hand make a tool for that, and it worked out really well. So you'll see that further along in the video. If you want to hang out and watch that, you want to fast forward to that, you're welcome to it. I show you sizes and everything and what works and doesn't work on that. I had to order a new speedometer gear and speedometer gear housing because the one that was in there was just roached. The gear was completely stripped, and then it looked like somebody took pliers and tried to pull something out of the housing from the front there. It was beyond repair, so I just got myself a new one. There's a set of numbers that you have to put the tangs in, and they clip in, and then there's a hold down bolt. I don't remember the torque spec for that right off the top of my head. I don't believe it's very high. It's definitely under 50, I think. Make sure you set that all the way. I thought I had it down all the way, and then that like Y-shaped hold down washer thing was not all the way into the grooves. It could still be wiggled, so then I had to kind of work it out flat and get it tightened down a little more. So just make sure you check that. And that is a nice, new, shiny front bearing retainer. Offhand, I can't remember the size of the socket I used. I think it's a 15-16 socket. Fit right on that seal. I was able to hammer that in. Takes a few tries because I wasn't really like beating on it. Just kind of gently tap it in. You know, you want to take it easy with that, but it's definitely got to get driven all the way home. So make sure you're seated all the way. And that is one clean looking, newly machined piece of metal. I did notice the repop part has a different set of numbers on it that comes from Brewers. So just realize that if you find one that has those couple digits on it, that it's probably not a factory one. It's probably a repop one that had to get put on there. Maybe someone else had got attacked by torque trolls on a rebuild and lost their front bearing retainer also. Now, since I put Permatex on stuff like I own stock in it, I had to go and kind of clean out some of the gunk off some of the holes from the last time I tried to set this front bearing retainer, and I even went as far as just cleaning some of the holes, running thread chaser in there. It doesn't hurt to make sure things seat good and have a nice clean thread path. Years ago, I never thought I would have the proper tools to professionally pick boogers out of metal parts, but that's what I'm doing here. Like I said, I overdid it with the Permatex quite a bit on a couple things here, and, you know, I'm learning as I go. Sometimes less is more. So I'm just picking that clean with one of the hook tools, getting out any visible basically Permatex boogers. You know, get a good clean fit. I soaked those bolts for a couple days, and that definitely helped loosen everything up. I think it had already dried on there completely, so I wish I got them in there a little sooner, but I think they sat for 3 or 4 days, so it helps. It just helps break down, you know, the amount that I had used on those bolts the first time. I definitely tried to use a little less this time. I use a combination of the thread chaser nut and wire brush to get everything off of there. The acetone did help loosen everything up, which was good. What I do is I throw it in a small set of vice grips. That way I can really put some pressure on the wire brush and not take all the skin off my fingertips, because that's never fun. Yeah, because you had to lay into it a little bit there and get them down to clean threads again. I'd say it looks pretty good. Nice clean metal. It's very easy to see the difference between the old one that still has the silicone on it and the one that I just cleaned. Here I'm just adding a little bit of grease to the end of the input shaft here. There's like a ridge, and it's just suggested in the book that you just add a nice layer of grease there. Wasn't sure how much. I didn't really slap it on there, but I put a couple fingerfuls, if that makes sense. You know, just a nice bead all the way around. So here's the new gasket that did come with the retainer, which is good because I forgot to order a gasket. I can't remember if I read that it came with one or not. And then after it was ordered, I was like, oh man, I forgot the gasket, but it did show up with one. Same style. It's like a partially rubberized type. So when it gets all lubed up with Permatex and gets a little torque on it, it kind of slides around a lot. Someone in the comments of the last video suggested I use a little bit less, and here I definitely do. I just kind of put like a bead, a very small bead on, and then kind of flatten it down. And I was mostly concerned at the bottom where the flat surface of the bearing retainer is the thinnest. It's at that spot for, how do you say it? The big groove that's notched in there. So that way the oil can return. So I do something here that might be a little unnecessary. When I put the gasket on, I flip the part over and just put a little weight on it by putting an item on top of it to kind of just like put a little pressure on that silicone. Make sure it's all nice and flat. I'm sure the city folk will appreciate that joke about me scratching my arm. Same cheap torque wrench as last time. I have not gotten a chance to order another one. I want to do a little bit of research and pick one that I think is suitable for the stuff I'm going to be doing. I know they make all different types and sizes and stuff, but I think maybe like a 1/4 inch or a 3/8 inch drive would probably be fine for me. And some folks were talking about getting a digital one. If there's one that you really like that you've been using for a few years and you think is better than another model, drop a comment in the bottom, say hello, and let me know what model you like. Because I'll definitely be on the market for one soon, and I don't know a ton about torque wrenches. But yeah, I think that's something that I should probably add to the tool arsenal and probably get a pretty decent one considering the stuff that I'm starting to put together now, requires accurate readings. I will say the Pass On book recommends that you put some silicone under the head of the bolt as well. So I kind of give it a little bit there. I went a lot lighter on the threads, but I leave a little bit because those bolts have sort of a built-in washer. They're a little wider than the hex that the wrench goes on. Excuse me. Excuse me. So I make sure to add some there. I don't know how much of a leak point that is, but if it's recommended in the book, I feel like they know better than me. So I'm just going to follow the directions on that one. I just want to add one little detail to this. Permatex doesn't taste good. I got a little bit transferred onto my food, and I feel like I could taste it immediately. It must have had a little bit on my hands, and I wash my hands when I'm done before I sit down and eat or do anything like that. And I must have missed some and got it on some of my dinner that night. And yeah, it left a really weird flavor, a real weird chemical flavor. So definitely keep that in mind if you're building any of these and you're touching that stuff constantly. It gets under your nails. It gets on everything, and it's not that easy to get off. It's kind of a pain. And I don't wash my hands in acetone. I just use regular soap when I'm doing that, or goop or something. But torque wrench did good this time. I double clicked each bolt. It was very easy because it was set properly to the 18 pounds. And yeah, you'll see much easier this time around. You know, the more I watch this while I'm editing it, the more I realize the main case was rolling around more than I thought. It's definitely difficult to get those things to sit still because there's nothing flat on the bottom of them. It's like trying to get it's like trying to get a watermelon to sit still. It just doesn't do that. So, something to keep in mind if you're trying to torque something down and get an accurate reading. So, in all my looking around the shop for a seal driver, because the ones I have are not, they're solid metal, basically. So they don't work. I have like bearing drivers. I decided to try this can, and it didn't do it. It actually just crumbles. And yeah, there you go right there. Whoops. Junk. I wasn't even hitting it that hard. One thing to keep in mind, that seal has a drainage hole, and you want to put that on the bottom. I broke out my handy dandy measuring tool. This thing works pretty good. Always make sure you set it on standard inches. Otherwise, it's going to seem really off. But yeah, we're about 2.4 on the seal. I think I opened it up a little bit, so there's just a little bit of slop. Yeah, it's like 2.39. But if you open it up with a little bit of slop, it's like 2.45, which basically we'll call that 2.5 inches. All right, so that's the size of the inside diameter of the driver that you would need to set that. And what I did is I looked around at work and I looked around in the shop, and I lucked out and found a piece of pipe that was close enough to the size that I knew I could use it as a driver tool. The only problem was the pipe was hollow in the front and the back, so that's no good. And I had to figure out a way to make this, usable as a driver tool, because I don't have a hammer bigger than the diameter of the pipe. So I just put a little piece of plate on the bottom and cut it pretty round and then welded it up. And yeah, it works out pretty good. I did get rid of that groove that's on the inside. There's like a little, I don't know if it's slag from when they weld that together. I don't know exactly how that gets manufactured. But I just tried to knock that down so I didn't mar the rubber surface when I set the seal. I'm sure there's numerous inappropriate jokes for the last minute or so of footage, but we'll just leave that alone and keep this nice and above the table, so to speak. I had some nice 3/16 flat bar stock. Worked out perfect to get welded to the back of the driver cylinder, or the cylinder that will become the driver tool. Yeah, so keep watching. You'll see how I kind of put that together. It's pretty self-explanatory. There's nothing special here. I do like it when I'm able to make my own tools. If it's a simple tool like a driver tool, just figure out a way to weld up your own, or find something that works and use it as the driver tool. It's a way to save $100 basically. After shipping, that tool would have cost me $100, and it's kind of ridiculous. I'm sure, yeah, if you bought the tool, you'd have it for a lifetime, but that's like a piece of 1/8-inch thick conduit, and it works just fine. Like, how hard are you really going to be hitting that? My tin can idea didn't work too good. As you can see, that thing crumpled right away. But hey, I had to check and see if it did work, and that led me to this, and that's fine. I'm okay with that. If you're doing stuff, you make mistakes, and that's how this works. If you're not making any mistakes, then you're not doing anything really, or you're not doing anything that you've never done. You're doing stuff that you've done before. So here what I do is I just put a couple dots around it, and then I use that as a line for my tape. So that way I could take it over to the bench grinder and cut a nice flat surface on the top. That way when we went to weld it, it wouldn't be all cattywampus. Using the tape as a reference line, it's easy to see the high spots that need to get knocked down a little bit. On a really funny note, I decided this would be a good project to try my new TIG welder. I stepped up and bought an actual dedicated TIG welder, and I hadn't gotten a chance to really run it yet. I had put it on the cart, put the cart together, and got the gas attached and everything, but I didn't realize how low I was on gas. And then when I went to use it to do this, I probably tried to make 5 or 6 tacks to hold these two pieces together, and realized my gas meter was on 0. I don't know if it leaked out when I changed it over. I'm usually pretty good about turning that off, but I realized real soon that that's why I was having such a hard time. So yeah, what I did there is I just cut the basic shape, but draw the basic shape and then cut it out, and then just round the corners over on the, oh yeah, that grinder wheel's no good. If they're chipped like that, just change them. It's not worth taking a piece of that, somewhere in a leg, or God forbid in your face or something, or even in your hand. They're going to tear you up. They're moving real fast. You won't see it. You won't have time to move, for a piece of material that's not that expensive. It's better to just change them out. But anyway, what I did is I just drew some corners on there, did some 45s, and then after I nick these off with the grinder, I just take them over to the bench grinder and take them down to like almost round. Like, this doesn't have to be perfect, it's just a quick tool to set a seal. It's not a machined part. It's just something I'm building. It's a DIY tool. So just get it close to round and you're good, right? I realized way after the fact that I had pointed the grinder wheel basically right at my phone, and I'm throwing all the sparks and everything right at the lens. I mean, makes for something interesting to watch, but it's not good for my camera lens. Here, the clamp kind of helped me a little bit, kind of ricocheted them off. And there you just saw me move an entire can of acetone off the workbench because I don't really like shop fires, and I don't want all my stuff to burn to nothing. Plus, if you have tanks or anything in your shop and you have a fire, they might explode. So these are things you have to consider when you're doing stuff with a grinder that creates this many sparks and they're flying all over. One of the things I often do is I keep a small journal about what I do in my shop and what I work on and the process and if I learned anything or whatnot. And I do that after I make a lot of cuts. That way it keeps me in my shop for a few minutes after the work is completed and I get a chance to make sure nothing's burning. Because you'll smell it. If something's burning, you'll smell it. You know, put the shop door down, write your notes for the day, or, you know, finish out what you're doing that doesn't involve sparks, and then just kind of make sure you're good before you go in the house. And you can see there, I had just traced with a Sharpie the shape of the piece of pipe and gave me a nice reference line for where to grind these corners down. I mean, it takes a little time to create stuff like this, but I don't know. I just feel better when I get to make little tools and stuff that help me do a job I'm trying to do, and, you know, I don't have to spend $100 on a round piece of metal. You know, like, car parts are expensive enough. Tools are even worse. I think my goal here was just to make it round enough that it was comfortable to hold while I was using it to set the seal in the tail housing. Just doing a little sanding here with a flap disc. Nothing crazy. Trying to clean it up a little bit to get better welds. I ended up just wiping this down with some acetone, and then after all the troubles with the TIG welder and realizing I had no gas, I came out the next day and just welded it up real quick with the wire feed. That's not in the video. You don't really need to see that. And like I said, it's no amazing welds. It was just enough to hold it together and make sure the tool works. So here I'm just aligning that drainage hole down to the 6 o'clock area of the tail shaft. You want it all the way at the bottom. Pass on, put the notch in the top of the seal so you can tell how to set it. And I tried it with a rubber mallet at first. That didn't really work. It wasn't giving me enough kick. So I grabbed the ball peen, like a medium weight ball peen, and it sent it home no problem. You know, you want to try and set these things as straight as you can. They don't always go in perfectly straight, but you want to make sure they're set straight. So there we go. And just like that, it's in. Thanks for watching. If anybody was able to learn anything, that's great. If you're just watching for entertainment, that's great. Have a good one, and we'll see you next time.